Hello everyone, welcome to another video. Today I actually wanted to show you something that sort of has to do with the Pong, the game programming in C videos that I'm making. So I've been working on something that converts Typescript to C. So something that I will be doing in the future is to make another set of videos where I convert our Pong C game to an actual game engine that can be reusable. And I will allow the developers that use that game engine to write like scripts and stuff in Typescript that actually will be converted to C and be completely compilable by the GCC compiler and completely usable by the game engine. Okay, the game programming in C videos will still continue as they are right now. But when I'm done with that series, I will start this new series where I create where we actually turn that into a reusable game engine. Where you can use Typescript, okay? The game engine will still be written in C, but you will also be able to use Typescript for like scripting objects and stuff like that. So I'm going to show you a little thing here that I got going. It actually works pretty well. So if I go to the project, there we go. The transpiler or the Typescript to C compiler, it's written in Python and it just basically converts the TypeScript code to C. This is sort of a work in progress thing, and it's also a sort of I wanted to see if it works. Maybe I will rewrite this TypeScript to C converter in C later. I don't really see a point of that though, other than I just like to program in C more than Python actually. But anyways, let's just see how this works. Okay, so for example, here I have some code that is TypeScript that it has a couple of classes. Actually, let's just write a new one. Okay, let's call this showcase.ts. Okay, so my transpiler or compiler or whatever you want to call it, it can turn TypeScript classes into actual C code, which is kind of funny because classes doesn't exist in C, so it's sort of a hack actually, by using structs and function pointers and stuff like that. There are features that doesn't work as of now. For example, you cannot have inheritance and stuff on classes. I am working on that right now, but right now it's very, very basic. Okay, so for example, we can create a class here called, let's call this dog. And also my interpreter is like very, very strict, so you have to put semicolon after everything. Yeah, I'm working on that too. And also, for example, in real TypeScript, you can just do like a constructor like this. But my TypeScript is sort of, at this point, very strict, and you have to actually type function constructor. Now this is, I don't even know if this is valid TypeScript. But right now my interpreter doesn't know if it's a function unless you put function before it. But anyways, I'm working on that and it should be fixed soon. Anyways, it's just very basic right now. All right, so maybe our dog has a member variable here called like message or something. No, let's just call this sound. Okay, so the sound is a string, and in the constructor, and also another thing that is sort of annoying with my implementation of TypeScript is that actually, I know the constructor isn't really going to return a void because it's going to return an instance of dog, but right now you have to do this. Yeah, it will be fixed pretty soon, right? And then you can just do this dot sound equals bark. Okay, and you know, in C you have to have a main method to make the code runnable. So it's the same here. You just do main function main, and then you can do like argc, which is an int, and then you have argv, which is a string array. Now this is I haven't really got the string like arrays and stuff to work properly right now, but this works. Like when you put an argument that requires to be an array, that is converted to proper C code. But like when you're instantiating string arrays and stuff like that, it doesn't properly work right now, but I'll get into that later. Anyways, here's our main method. And now we can actually like create an instance of a dog here. So for example, we can do let my dog equals new dog. Okay. And maybe our dog should have a function to actually bark as well. So maybe we should do function talk, which also will return a void. And then we're going to do console.log this.sound. Okay. Now we want to call that function as well. So mydog.talk. And hopefully everything will work now. Yeah, let's just try that. So now what you do is that you do Typescript examples showcase. Cool. Now we have a main.c file was generated. So cat main.c. This is the file that was generated. Let's actually format it. clang format main.c, because the file is sort of ugly when it's generated, but we're using some formatting tools to make it pretty. So let's just look at it. What was oh sorry, that's wrong. What was generated here? Wait, actually let's do this. Formatted.c. I think that should be working. Formatted.c. Yeah, here's the pre-code. So first off, my transpiler or compiler puts in some bootstrapping stuff because the console object doesn't exist in C, so it's trying to mimic it with the log function and stuff. So that is what you see in this block. That's the bootstrap for the like console object. And then we have some other bootstrapping stuff where it's just basically initializing the console object. And then comes our like business logic that was transpiled. So here's our dog object. Here's our dog constructor. Here's the dog talk method. Yeah, so everything looks fine. Now we can actually compile this code. So gcc main.c, and we're getting errors. Has no. Oh, let's just transpile again because I think we made a typing error here. Showcase. So yeah, talk fun. Yeah, we had two L's there. Okay, let's transpile it again. There we go. Let's compile the main.c. argc has an incomplete type. Oh, sorry. Number. Okay. There we go. Cat, no, gcc main.c. And now it actually compiles. We do get warnings because the code isn't completely optimized. It does have some typing problems, but it does compile, and you can actually run this now. So there we go, bark bark, and we can change this to hello YouTube. We can transpile it to C again. compile the C code, run it, hello YouTube. So yeah, this is pretty cool, right? And yeah, for example, now let me show you something about the like strings that doesn't work right now. So for example, if we remove everything here and we do let my list string equal hello world, and if we now transpile that, whoa, yeah, for example, there we got some recursion error things. I don't know why that is happening. But yeah, there are still some sort of some bugs in this transpiler. But yeah, this is the plan. I'm going to make this work really nicely and have it integrated into the game engine that I'll be working on later, so that you can actually write like game objects using Typescript, which is pretty cool. So another cool thing that I am actually supporting right now is, for example, the constructor can take in an argument. For example, maybe the argument should be the sound. So if we do sound string, we can do this.sound equals sound. So now you actually have to say what the dog is going to say. So let's put in passed in from constructor and transpile it, compile it, run it, passed in from constructor. So yeah, you can actually have function arguments and stuff like that too. Let's format it again. Let's just look at it again. Format it. So let me show you a little bit how I solved the thing how I solved implementing classes. So basically, all classes are structs. So for example, our dog here becomes a struct, which has some member values. For example, it has the variable sound. It has a function pointer, so a function called. It has a function pointer that has the return type void, which is the constructor. And we have the talk function pointer. And then methods are generated accordingly to these function pointers. And then we have the memory allocation for the dog. And we're setting the values of it. And then we're returning it. And yeah, as you can see here, we have some extra semicolons here and there. That's just a bug in my transpiler. And here's the main method. And it's initializing the bootstrapping. It's creating the dog. And it's running the dog constructor by passing in a reference to that dog. And then it's running the talk method on that dog. So that works pretty well. And another thing that actually is working right now is like while loops and stuff. So let's just do a simple while loop here. While one console.log infinite loop, transpile it, type transpile, compile, run, and we get an infinite loop. So while loops work, and if statements also work actually. So for example, if we do let x number equals 1, if x console.log it is true, Typescript compile, it is true. And if we set that to 0, it should not work. No, exactly. So that works. Else statements also work, so you can do else, blah, blah, blah. So yeah, but yeah, so what's missing now is, well, there's a bunch of stuff missing, like for loops doesn't work, and obviously we have some problems with lists, and also it's not very nice to type semicolons after everything, and also the function keyword shouldn't be necessary everywhere. That's a bug. I actually have a GitHub repository for this that you can look at if you want to. So yeah, here it is. Typescript to C compiler converts Typescript to C. Yeah, string list doesn't work. Number list doesn't really work. Addition, mathematical addition works. Mathematical subtractions works. Mathematical multiplications works. Division works. While loops works. Interfaces actually sort of works. They right now they're just converted to structs. So for example, if we do interface my interface, and maybe it has a age number, name string, and if we transpile that and we look at the main file, we can see that the interface is just turned into a struct, basically. Yeah, and here is also a bug. The bootstrap function is being called, even though the bootstrapping isn't really needed here. The bootstrapping right now is only needed if you use the console object. So for example, if I do console.log hello, then the actual bootstrapping for that console object will be initialized. It detects that automatically. And yeah. Another thing that is sort of interesting is that it analyzes your code and it injects include tags if it thinks that you need it. So for example, if we wouldn't do anything here, we probably wouldn't get any include tags. Exactly, we don't get any include tags. But if I add a class, it's going to have the include for being able to allocate memory. So if I do class dog here, it's going to right. So currently the dog has to have some content. It cannot be empty. That's also a bug. But if I do like sound string, like the transpiler is going to automatically detect that you're going to need to include the include tag to be able to allocate memory. Okay, so if we do that again, no, that didn't work. Has no. All right, so currently we have to have a constructor as well. Sorry, that's also a bug. I'm discovering more and more bugs here as I make this video. There we go. So now you should see that it has actually included stdlib.age because it knows that it's going to need the calloc method, okay? So it's sort of smart when it comes to that. But yeah, so I hope you will be looking forward to that new series where I turn the Pong game into a game engine. But this, as I said before, this will happen when the Pong game is done, because we haven't finished it yet. We just got something to render on the screen, right? So, but yeah. But for example, like when we turn it into a game engine, you will be able to like access the game engine methods from the TypeScript code. And you will be able to do like class pong ball, and it will have like maybe extends actor from the game engine, and this class will be from the game engine, which will be exposed. And you will be able to write like game object implementations in Typescript. That will be super cool. That will be converted to C, so you will still have the speed of C, but you'll have the comfortableness of Typescript. Okay, so that will be really cool. I'm really looking forward to that. So I hope you are looking forward to those videos as well. But yeah, thank you for watching, and I hope I see you soon.